Madam, good evening, madam.
Yes, sir. Yes, another few more minutes will be starting, sir.
No problem.
Yes, thank you, sir. Good evening, ma'am. Ma'am, shall we start, ma'am? Ma'am, shall we start, ma'am?
Yes, we can start the session.
Yes, ma'am. Dipansh?
Sure, ma'am. Okay. So, once again, good evening to one and all present here, and welcoming you all to the fourth day of our faculty development program on competing with AI in the classroom, discover and transform. It's truly wonderful to see your active participation, and I hope you all found yesterday's session on AI for academic content creation with tools insightful and thought-provoking. Today, we continue our journey of exploring the evolving role of AI in education. And before we begin, I request all the participants to first turn on their camera for a group picture. So everyone can turn on the camera. We'll take a quick picture and then we'll proceed. All the participants, I request you to just turn on the camera for a quick picture. I hope we can proceed from that. Okay, so, well, let's quickly hover over a few keynotes. So we kindly request everyone to keep their microphones muted during the session. If you have any questions, please use the raise hand option, and the feedback and attendance link will be shared in the WhatsApp group at the end of the session. Kindly make sure to fill it out once the session concludes. And finally, the session is being live streamed on YouTube. You can revisit it later, and feel free to share it with your peers and in your communities. Our YouTube channel name is School of Management DDGDVC. I repeat, it's School of Management DDGDVC for your acknowledgement. I now invite Lavanya to introduce the speaker of the day.
Thank you, Dipansh. It is my immense pleasure to introduce our distinguished chief guest. Dr. SRINIVASULU Reddy received his PhD in 2013, Department of Computer Application, National Institute of Technology, Tiruchirappalli. He started his academic career as a lecturer in the Department of Computer Science, Bishop Herbert College, Tiruchirappalli from 2003 to 2006. He started his research career as a full-time research scholar in the Department of Computer Application, NIT Tiruchirappalli from 2006. He joined NIT Tiruchirappalli as an assistant professor in 2008. His research interest lies in applying various artificial intelligence approaches to extract useful patterns from different facets of societal challenge, of high demand with economic benefits. The main aim of his work is to develop machine learning and deep learning models for various domains like agriculture, bioinformatics, banking, telecom, and healthcare. With this motivation, he has established Machine Learning and Data Analytics Lab in 2015, and he is a core team member of the Center of Excellence in Artificial Intelligence established in 2020. His research team of 12 doctoral students, 10 postgraduate students are highly motivated and enthusiastic in working out to achieve better outcomes. For his credit, he has produced 10 doctoral till date and 10 post-graduation students annually. He has published more than 64 journal articles and conference and 4 book chapters. He received Best Researcher Award in 2018 and the recipient of the Best Performer Award for 3 consecutive years, 2019 to 2021, from NIT Tiruchirappalli. 2 Best Paper Awards in IEEE International Conference, recognized among the world's top 2% scientists for 2023. His work in AI and image processing, he received a full educational scholarship under Residential Care Program from KNH, Germany, from schooling to masters. He received various research grants worth of rupees 1 to 7 lakhs from various funding agencies such as Indian Space Research Organization, Naval Research Board, Defense Research Organization, Department of Science and Technology, and Department of Electronics and Information Technology. He conducted many national workshops, conference, and training programs. Dr. Reddy has delivered more than 50 invite talks in national and international conference, workshops, and faculty development program. He is a live member of Computer Society of India, an annual member of ACM, IEEE, and Analytical Society of India. Sir, we welcome you to the session. The session is all yours. Thank you.
So, good evening to all. My voice is audible?
Yes, sir.
Yes, sir.
Yes, sir.
Thanks for inviting me. I will share my screen and my screen is visible, madam?
Yes, sir.
Yeah. So, good evening to all. So, thanks for the invitation and a nice introduction. So, today, 4th day of this FDP program. So, briefly, I will 1 hour session. I will go into depth, not going to full depth, but I'll give the glimpse what AI can be, how AI can be used in different areas, how we can use AI, the computing AI in classroom, discoveries and transforms, right? So that is the title of your workshop. So I was wondering that after looking the title, right, how computing with AI in classroom, what are all the discoveries they made through AI, and how the invention of AI models transformed our education system or our industry or any sector. If you take any sector, for example, either agriculture or medical or transportation or your education, everywhere now the AI is a part and participle of all your programs. Now, why AI has become so popular nowadays? What is there in that? How we can teach the AI concepts into our students or our faculty to enrich their knowledge, and not only to know about the AI, what are all the applications of AI, where we can apply, and how to get best benefit of the AI tools in our day-to-day life. So that's what the AI is focusing nowadays. It is simplifying human work, and also it will minimizing the manpower and minimizing the complexity in your tasks, but it giving efficient results and effective results. Okay, what is that AI? First of all, what is the AI? How it will work? What are all the different models are available? Then how we can utilize that into our classrooms? So now see this diagram. What is this? everyone knows, right? Mimicking the five senses, human five senses. So what is the five? These are all naturally we have. What is that? This one is a vision, right? So everyone, from this, what discoveries they made? What discoveries the art? What innovation happened in this? So based on our human vision, somebody turn on their mic, please mute that mic. Now, with human visions, now they developed one concept called as computer vision. This computer vision is the future of artificial intelligence. CV, computer vision is the future of your artificial intelligence, AI. Okay, why we are calling, see, everything you are visualizing and interpreting. For example, you take a simple example, take a Google map. Okay, Google map, their Google map works based on the GPS. What is the GPS? Global Positioning System. So it will help you to go from one place to another place. So that based on the source and destination, GPS work. Same Google map, now they're using VPS. What is that VPS? Okay.
Global Positioning System.
Visual position, very good. Visual Positioning System. What is the purpose of this VPS? It will visualize. If you open your Google map nowadays, you can see your streets or buildings, pedestrians and pathways, everything. Okay, that has been happened from this. Where this discovery, where this has been, from the human vision technology. From the human autonomous vehicles, your FASTag, all the examples for this. So these are all the discoveries made by human eyes. So now that naturally, if you go someplace, you visualize the room, you visualize the road. When you get into the bus, you visualize where the seat, everything. Now people are mimicking that and making your models or your cameras, smart cameras, right? Now whatever the surveillance cameras we are using nowadays for security purpose and all, that making as an intelligent cameras. Why they call it intelligent? They can take decisions. For example, in presence, right? For example, now in toll gates we have different cameras there fixed. So when the vehicle comes, that time only it will activate and will read that thing. But till that, it will be not storing any data. In presence, right? Any object is coming near to that they're making intelligent sensors. Like that, if reverse gear, you take in an automobile, right? A car, you make a reverse gear, any obstacle it is nearing to it, it will give the alarm sound. So how it is giving? So through sensing, right? Even now, in the previous days, what we used to do, somebody was standing reverse of the car and telling the sign and go back, stop like that. Now no human invention is required, and automatically your vehicle is able to detect what obstacle is there. So that is a smart intelligent transportation, right? In transportation extensively they're using these vision sensors. So this is the one innovation happened in AI with our human eyes, whichever is naturally human has, that they mimic and make an intelligent system, artificial thing that is in a computer vision. Through ears, a lot of Siri, Alexa, all that things there. Through skin, you all touch screens you are using. Now, see, let me explain this sensor. What is any sensor from this? Anyone from this? From this, any sensor they develop or any discovery from our nose?
Smoke detector.
Very good, sir. Smoke detector. Smoke detector, it will detect the smoke where it gives the file an alarm, right? Now, they're making this as an e-nose. What is that e-nose? Electronic nose. Electronic nose. Electrochemical biosensors they use to detect not only smoke, even now we are all our human people, all our country now, not only our country, in all throughout the world, we are depending on the packed foods. How do you check whether the milk is fresh or not? How do you check? How do you check the milk is fresh or not? Anyone? Previously, we have taken from the cow or a buffalo and we are taking and we are drinking that milk. Now we are getting into packets, Avin or Arogya or whatever it may. They give an expiry date and all. What is the guarantee that really that is in a fresh or not? How do you check the milk is fresh or not? Through smell. Through smell only. When boil, that time only your milk is telling whether it is in a fresh or not. So now the Shastra University near to Tanjavur, the Shastra University, they developed electronic nose to detect whether your Avin milk, whatever Avin you are supplying, no, that milk is fresh or not. So that is the innovation happened through this nose, electronic nose. Another one example, last month I gave one talk for a coffee beans. How do you check the coffee seeds are in a quality or not? Through smell. In a coffee they prepared, now the smell will come, right? So through that, now they are using in Bangalore, one company, they demonstrated how they're using electronic nose to test the coffee seeds, quality of the coffee seeds. So that is an application. Now how our nose is able to detect a good smell and bad smell. So now that they mimicked that mechanism and they discovered an electronic nose for different applications. So another application is whether your plant or your fruits are healthy or not. How do you check? So that can be checked. When if you have a healthy plant or a healthy plant, it will produce a very good smell. So reason for that is they exhibit one compound called as a VOC. What is that VOC? Volatile organic compound. So that reasons whether if any diseased plant is there, it will definitely give kind of bad smell. So that can be detected by using electronic nose. Another one is a very important nowadays, green energy, right? Now we have a green gas emissions. Different gases will be emission, produce carbon dioxide, carbon monoxide, what is the methane, ethane, what is different gases that can be classified and smell it through this electronic nose. With the help of this electronic nose, we can classify first with the smell, some gas is coming or some that smoke is coming. From that smoke, we can classify which kind of gas it is. So for that, they use in a deep learning called as a gas net, okay, NET. Gas net is a one deep learning model which can classify that. So with the help of these two, we can, many times now in a metropolitan cities, if you go, they'll display the digital board. Carbon dioxide this much, carbon monoxide this much, and that different emissions of gases, that concentration they are displaying. That is through our natural things they are doing. Similarly for tongue. So these are the 5 sensors normally human has, these 5 sensors. Now they mimicked the mechanism of these sensors, making it artificially. That is called artificial. So artificial intelligence is man-made intelligence. Definition for artificial intelligence is man-made intelligence. What is that artificial intelligence you see here? The making intelligent missions. The purpose of AI is to making intelligent missions. Why we call intelligent? Your smartphones or your devices should be intelligent. The missionary, you should be intelligent. What do you mean by that? It has to take decision on its own without being explicitly dependent on somebody or without being explicitly dependent on some programming. So that is making intelligent mission. So now how this intelligence we develop? How you got that one? So based on these 5 senses, how this mechanism works, right? Now see this slide. 1950s they developed AI, but now year is 2025. Okay. So what was there in the previous? Why this become now so popular? Anyone? Why this AI has become so popular nowadays? Even though it was introduced in 1950s, Now we are in the year 2025. What is the reason now AI becomes so popular? Anyone? Why this AI become so popular? Because now we are today topic is also computing AI in the classrooms, right? Discoveries and transforms. And now why this AI becomes so popular? What was that? Even though they were in 1950s, it was there. What was the transformation happened? What are all the different discoveries happened from 1950s to now? Very simple. We in olden days we have the data we are getting from the satellites and all, and apart from the data we are limited with the computing power. We only depend on CPUs. What is CPU? CPU is
Central Processing Unit.
Right? We had a limiting computing power. So for example, very simple to understand means, easy to get the concept means, when a news reader will read all the news, at the end of the news, one person will come and give the weather forecasting. They will tell in a previously 5 years, 6 years back, or 10 years back, they will tell tomorrow will be heavy rain, but they'll never happen. Why? Because of they don't have computing power to accurately predict. So now this problem has been solved by using this one. What is this one? GPU. What is GPU? Graphical Processing Unit. What is there in this graphical processing? This computing power is available in terms of GPU. Inside the GPU, we have inherently massive parallelism. We have inherently massive parallelism. It is computing huge data, can be processed within a seconds. 10 to the power of 18 operations per second it will happen. So in GPU, because of the GPU is available in NVIDIA, right, and GPU cards, that's why this inside this machine learning, so the deep learning mostly use these GPUs. The deep learning mostly use GPU. What is that GPU? Inherently it has massive parallelism. Now, what is another problem now? In deep learning models, you want to train these deep learning models, it will take a long time. That means a lot of time required to train that one. But testing and evaluation is very easy. But to train with a huge big data, it requires more time to compute or to process or to train these deep learning models. How this now can be handled? So now from GPU to now current trend in going to be this one. What is this? QPU. Now we start with the GPU. GPU, Central Processing Unit. We have limited computing. The computing speed can be increased with the help of GPU. What is the issue in the GPU? Deep learning take lot of time for training. So now they are going for this one. What is this expansion? QPU? It's going to come in
Process.
It's going to come in near future. That we call as a quantum processing unit. That we call as a quantum processing unit. Yet to come into the market. What is there in that? We have a qubits, superannuation, or entanglement. Because of that superposition, qubit concept. Now this as more faster than, it will more faster to compute with compared to GPU. So because of these computing things are available now in the form of hardware, the chips, now your AI becomes so popular. Because of that, your AI become so popular. Okay. So now even though it is developed in the 1950s, now why we are studying in AI nowadays? Because of that computing power, because of deep learning become so popular, because of the GPUs only. Now, what was the first approach? What was the first approach in AI? There are three approaches in AI. three approaches in AA. One is expert-based approach. This one is the expert-based approach. Second one is intelligent-based approach. Second one is intelligent. What is third approach in AA is learning-based approach. Learning-based. These three only I am going to discuss today. What is the expert-based approach? Whom do you call expert? The person should have in-depth knowledge, wide and in-depth knowledge in a particular field. So that person, we made it as an expert. But fortunately, unfortunately, all our problems in a real world are dynamic in nature. Every time it gets changes. So now this expert system works based on rule-based. It fully works based on rule-based. Writing a rule for static system are easy. Then dynamic system is very, very tedious. You can write the rule for dynamic system also. But writing a rule for dynamic system is very tedious because it is keep on changing. So we cannot devise the rules. We cannot stick, this is the rule. So now, for example, your taxation, you take previously we had a VAT. Now we have a GST. Tomorrow we don't know what will come. So if you're dynamically changing the system, then how expert system will devise the rules? That is a very, very difficult and tedious task of expert system. That made a limited applications of expert system. That is the first approach of AA. First approach of AA. What is second approach? Second approach is intelligent approach. What is that intelligent? Where do you get that intelligent? How do you measure that intelligent? For example, whom do you call intelligent? The person who is able to respond, or you can give the response in a quicker manner, is the intelligent person. So how do you measure that intelligence? Based on intelligence can be measured by using, what is that? IQ. What is that? Intellectual quotient. Now we have 4 Qs: IQ, EQ, SQ, and AQ. It's very, very important in nowadays in everyone's student life. So what is that? Your intelligence can be measured through intellectual quotient. Not only you have an intelligence, it's not sufficient to survive in your life or in a survive in an organization. You should have the emotional quotient. Emotionally, your emotions can be controlled. That can be measured by emotional quotient. How you are behaving with a society or a group or in a department or in an organization, that is a societal quotient. What is the last one? AQ, adversal quotient. So you can, in adversal situation happen, how you handle the situation. So these 4 Qs are very, very important in nowadays. Now Gen Z are more having issues with this emotional quotient. They are not able to control their emotions. They are not able to mingle with the society because of the addiction to the mobiles. Okay, then any small adversal situation happen, they will take extreme steps. So this we have to teach the students to handle this intelligence. Now, how do you measure this intelligence? IQ. So what it differ in this IQ? See, because this is all, if we are having now 30, 40 students in online, okay, everyone has same IQ. Everyone has same IQ. Who are
No, sir.
this class?
Different.
Different. Why it is different? Why it is different? Sorry, correct, sir. You are exactly correct. Now, why it is different?
That IQ is different. Each and every one.
Yes, sir. Your answer is correct. Why IQ is different? Because same moon, same sun, right? Same 24 hours, same class.
Environment decides.
Environment, very good. Then
Situation. Where they are.
Very good. One start with the P, a very important one. Even though they are in same environment, the IQ also changes because of their perception, the way they perceive the things, the way you perceive the things. That same perception differ from person to person. See, how many people might have sat under the tree? Why Newton alone got that idea? How he perceived the things. Okay, that differs. Your perception differs, right? Perception is vary from person to person. So that it differentiates your IQ. So where do you get that perception? So this you see here. Simple human brain. Inside that brain, what is there? We have a basic entity called a neuron. How many neurons? We have so many neurons. All are connected. And now who made that connection? God only. So that connections, that exchange of information between different neurons are called a neural network. So that is naturally happening. Now first intelligent approach they developed is based on this approach is called artificial neural network. This is the base for all your intelligent models or AI models, if deep learning, anything you take. Neural network is the base one. Based on the neural network, they made it as an artificial neural network. It is a system. Any system has three components. What are the three components? One input, then output, right? Then process. Here in the same, the process layer, they made it as a hidden. So this we have an input layer, this is called a hidden layer, output layer. What is input layer? Input x1, x2. I'm asking some questions, right? This one. Now once you ask the questions, immediately what you will do? You will process something, right? What you will do? You will assign some weights for that question. That we call as W1, W2, up to so on, Wn. So this x1 is my question, x1, x2, xn are my questions. Now for each question, you are assigning some weight. This summation is called, now we can write very simple equation, this y equal to this x1 w1 plus x2 w2, so on up to so on xn wn. So this is a simple network, neural network formula. Now you are giving someone, even if you ask students, students will get some answer, but they will hesitate to tell. Why they hesitate to tell? There are some control mechanism. They'll have fear that this we call as an activation function. This activation, purpose of activation function is introduce non-linearity. This also we call as a threshold function. So the student, if I tell that answer, it may go wrong. So they will not open their mouth. Okay, that controlled by this pi value, summation of this. You cannot get always first time itself. This is your actual, this is your predicted or given answer. So this difference is called error, right? First time itself you will not get correct answer. So then what you'll do? You'll go back and adjust these weights. You go back and adjust your answer. So then why you adjust this answer? To minimize this error. To minimize this error. What is this error? Now the difference between actual and predicted. This should be decreased. How we can do that? For that they'll use one beautiful algorithm is called back propagation algorithm. Back propagation. Simple, very simple to learn this concept. When you adopt human analogy, how you correct your answers, you go back and think, oh, this may be the answer, this may not be the answer. You keep on thinking, right? That thinking, you go back, and that we call as a back propagation. Back propagation. Why you do the back propagation? To adjust the weights. How do you adjust the weight? Till you will get an optimal weights. What do you mean by that optimal weights? The weights which are minimizing, what is this? Minimizing your error. Minimizing your error. This is the one back propagation, one algorithm. Another algorithm is gradient descent. This error, they call it as a gradient. So now my error is here. Now the error should be reduced. This we call it gradient descent. Descending. The error is reducing. For example, first time I got 0.7. Next iteration, I got 0.5. Then this should be decreased. Almost it has to come 0.0. So that we call as a gradient descent. So this way our neural network, our brain will work. This way our neural networks will work. So now same thing they transforming into, they discovered how ANN, how our neural network systems works. Then they transformed that into a model. Okay, that we call as an artificial neural network, ANN. For example, Now, many of you studied, maybe you might have studied linearly separable data, non-linearly separable data. What is linearly separable data? Very simple way to explain. We have AND gate, OR gate. You might have seen. What is AND gate? Truth table you might have seen. 0, 0 means output also 0. 0, 1 means 0, 1 means 0. 1, 0 means 0. 1, 1 means only 1. Whereas in an OR gate, we have 0, 1, 1, 1. How many classes we have here? How many classes?
4.
2 classes. What are the 2 classes? 0 and 1. Right? Now see this one. Same thing I'm writing as a coordinates. Here what is the coordinates will come? 0, 0. Here will come as a 0, or 0, 1 or 1, 0. Here. This one. Same x-axis is 0, y-axis 1, then 1, right. Now see this data. Now we have 0 and all. Now if you draw one line, for example, I draw one line. So all these classes are 1. This class is 0. What is this gate? AND gate. Now see, same data I am taking. Here, this R. What I can do? Draw a line here. This is OR gate. What is this? These are all 0. Both the 0 means your output is 0. Remaining times all these combinations, whatever the combination you take, okay, your output is 1. This problem is called linearly separable problem. When data, your output is linearly separable means with a single line you are able to separate your classes. That is called linearly separable problem. If your data consists of this type, then you can use algorithm is called SLP. What is SLP? Single layer perceptron. Single layer perceptron. I told you why perceptron is very important in an intelligent approach. If you take XOR gate, you might have seen XOR gate. Both 0, 0. This is 1, 1. If a single line you can't classify this. At the time, see, if you see, these two comes to one class, these two comes on one class. This is not linearly separable. XOR is not linearly separable. At the time you use MLP, you might have seen. What is that MLP? Multi-layer perceptron. So now you have to see these differences. Not only this ANN has 2 types. One is seen linearly separable. Other one is not linearly separable, means you have to use multi-layer perceptron. These things we should know. Right? How we got this intelligence? Based on our neural network. What is second intelligent approach? What is this theory? Evolutionary theory. Right? So from this evolutionary theory, here in brain, your basic entity is neuron. In evolutionary theory, what is the basic entity? Is a gene. What is a gene? What is a gene? When you stress the chromosome, we'll get a DNA. Entire DNA is not a gene. Only segment of DNA which has the ability to produce protein, that we call as a gene. So based on the intelligence of the gene, they developed a beautiful algorithm. What is algorithm that? Anyone? Based on this intelligence? By adopting the intelligence of this gene, right? Anyone you might have used in a different places, or maybe in some your thesis, or maybe in your research work and all. Which algorithm they developed? That algorithm is called genetic algorithm. So based on the gene intelligence, they developed. It's a beautiful algorithm. This we call as a soft computing, global optimization techniques and all. Right? Now see next algorithm. Particle swarm optimization. Based on the behavior of the birds, based on the fish's behavior, this particle is nothing but either fish or bird. Based on swarm is nothing but a group. Now what is optimization? Either to, what is optimization? either to minimize your objective function or you maximize your objective function. Based on these two, either to minimize or to maximize. When to minimize? Any raw material, cost, labor, all these things is there, you minimize. When to maximize? Accuracy, efficiency, profit, and your productivity, that you can maximize. Now, what birds will do this? Birds will do both these things. While morning times or evening times, you might have seen these birds flocking as a group. They never collide each other. But what for they'll do? What for they're going? They're going for search the food. So what they are applying this optimization? Where they are applying? One computer scientist and ecologist, they studied the birds and fish behavior and found out this algorithm in 1950s. This is the global best optimization algorithm. Global best algorithm, right? Why they call it global best? Always it will give the global best solution. So what it is trying to optimize? What is trying to optimize? Two things they do. One is it minimizes the distance, the travel distance it will minimize. Birds travel distance it will minimize. What it maximize? It will maximize the food. There is no leader. No, only in each iteration one bird will take the lead. That bird we call as a G best or a local best. So based on this beautiful, right, the birds and the fishes intelligence, they developed this beautiful technique. Very simple formula, very simple formula. Now you have to update the velocity. That's all. What is that velocity? Is inertia weight W of previous weight. What is that previous weight? T. Okay. Then it will be multiplied with C1 R1 and that position minus P best. What is the P best? That means particle best. Each particle best I. Okay. Then this VT will come plus VT plus. Okay. Not here. Into this. Then C2 R2 XI your position minus G best. Only one G best. Okay. So this is the formula for updating the velocity. Velocity means speed. So now position XI. Initially we have XI position. You want to get a new position. XI plus T. So how we will get that position? So already XI position, current position plus this you add, you will get a new position. Only these two formulas, that's all, nothing else in this. But it will always solve the NP hard, NP complex and complex problems. So where do you get these concepts? Okay, how they can discover this algorithm? Because they studied the behavior of the birds and fishes. Okay, then by that intelligence, they developed this. Okay, not only this, right? Another algorithm you see. What is this one? Ant colony optimization. Okay, here also optimizing ant. It's the smallest creature, but it will give a beautiful. Always it will find the shortest path. Ants will go like this. If you do some obstacles in between, then what you'll do? Randomly will go like this. Randomly will go this. After some times, all will take shortest path. All will take shortest path. How they know this is the shortest path? When ant moves, right, it will release some pheromone. They smell that pheromone. More number of ant passes through, more number of pheromone will be released. So then that pheromone evaporation rate theta we have to calculate. So this is a very good. These two algorithms are also called as swarm intelligent techniques. These two algorithms are also called as global optimization techniques. These two algorithms also called as meta-heuristic techniques. These two algorithms also called as bio-inspired algorithms, nature computing, soft computing, all are same. Right? Now see the soft computing. So next one is fuzzy logic and fuzzy system. What is that fuzzy logic and fuzzy system? Human brain is always in fuzzy. So now see this. What is this one? For example, you have data like this or data like this. Which one is fuzzy? Which one is crisp set? Which one is fuzzy? Which one is crisp? Among these two sets. This is the crisp set. Why it is called a crisp set? It clearly will tell whether you choose the 0 or 1. What is this one? Fuzzy in nature. What is that fuzzy in nature? Always either between this 0 and 1, we have infinite numbers. We have infinite numbers. So for whenever you use this fuzzy, we have to use fuzzy membership. What is that fuzzy membership? Okay, which member has going towards this or towards this? Majority membership you have to take. You have 0.89, then this is positive value. It is towards the positive value. 0.19 means it is towards the this 0 value. So it decides trapezoidal or the different fuzzy memberships are there. Our human brain also like this. Many people are attending this course, will also attend the course. Many people now, everyone is behind the AI and MLDL. Right now that IIT director also said, there are a lot of demand for AI and ML and data science and data analytics. But after 5 years, what is the demand? So because many people are opting this course, people are going majority of this. Right? A human brain works like that only. Whoever choosing a good field, right? Our mind also says. So that they mimicked and developed another approach. So now, what was the first approach of AI? AI has 3 approaches. What was the first approach? First approach is expert-based system. What is second approach? Intelligent-based system. Right? What was the third approach? That is very important. Before going to third approach, you see this diagram you might have seen many places. Now this AI is a set. Within that machine learning subset. Within that subset is deep learning. So now what is this data analytics and data science? Is there any difference between analysis and analytics? Or both are same? Analysis and analytics. Both are same or different? Anyone? Analysis and analytics. Both are same or different? I'll take 2-3 minutes in data analytics, then I will move to another topic. Both analytics and analysis, both are same or different? So both are not the same. Both are not the same. Analysis is the process. Analysis is the process. Analysis is the process. What is analytics? Making intelligent decisions. Making intelligent decisions. How do you make this intelligent decision? You want your decision. When do you say it is intelligent decision? If it improve your ROI. What is ROI? Return of investment. I invested this much. In turn, what is my returns? If your decision is improving your ROI values, that decision we call an intelligent decision. How do you make that intelligent decision? By applying different analytics. By applying different analytics. What are the 3 types of analytics we use? What are the 3 types of analytics? Anyone? You might have seen, because all MBA, many places will get that analytics, right? What are the 3 types of analytics? Very important now in machine learning, deep learning, AI, wherever you go. It is a part and participle of our life now. What are the 3 types of analytics? Anybody? This one. Descriptive, predictive, and prescriptive. Descriptive means describing. How you will describe this phone? Color, shape, features, right? How you describe this water bottle? Like that you have to describe your data. What is the mean value? What is the median value? What is the mode value? What is the minimum value? What is the maximum value? How my data is distributed? Whether it is skewed or it is having a left skewed or right skewed. For example, very simple. Now in weekdays, now today is a Saturday, tomorrow is a Sunday. So what about our demand for private buses? Very huge. The prices will go high. Movie tickets go high. That problem is called dynamic pricing problem. How they are calculating the dynamic pricing problem? Based on the statistical concept. What is this statistics? This one, kurtosis. What is the kurtosis? Kurtosis. Now peak values, the mode values. Now number of people are hitting that site automatically go into peak. So if it cross some threshold value, increase the price, right? So that comes from the kurtosis. From these kurtosis, they're taking kurtograms. That means the peak values. Whatever the peaks are there now, they're taking that. Now even if in an electrical vehicle, e-vehicles, they want to do charging, they're telling that it is a smart charging. What do you mean by smart charging and normal charging in an electrical vehicle? When your vehicle suggesting you when off peak hours, that means no demand is there, that time your cost will be reduced. So that is called smart charging. That they identify, they discovered that thing with the incoming vehicle and leaving vehicles. They are taking the distributions. Then they are identifying the peak values. That peak, when is the demand time, and that. So based on that, they are calculating it. For all the things, they are using full and full statistics and probability only. So that they are using descriptive analytics. Descriptive analytics is nothing but describing your data. What is the minimum value? What is the maximum value? How it will use? Then second analytics is predictive analytics. Predicting is nothing but predicting unknown value with help of known values. For example, you see this, y equal to mx plus c. What is this? Simple line equation. So here, what are the known quantities? X and y are known. Okay, unknown is m and c. Now what you are going to predict? Now you are predicting without knowing m and c. Any value are given to x, you can't predict y. If you know the values for m and c, that you substitute here, right? Then you given any new x, okay, you will predict the y. Same thing they are getting into here. What is this equation? Anybody, this equation? What is this equation? For prediction, what will you use? Anyone? Right? Regression lines. So here, these are all regression coefficients. By predicting values for beta naught and beta 1, now substitute any new x, you can predict y. So this regression can be divided into two types. One is a linear regression, non-linear regression. Again, linear regression divided into two types. What is that? Simple linear regression and multiple linear regression. When a simple linear regression is very easy, only one independent variable, then we use this. More than one independent variable, go for multiple linear regressions. Okay, that is called a predictive analytics. Last one is prescriptive, is nothing but optimizing your values. So this is the thing we use in a data analytics. So now data analytics is the practice of using machine learning algorithms and visualization to derive insight. Now what is the data science? Blends the data analytics in computer science, business domains, expertise to solve the business problems. Now data science using data analytics using machine learning. What is that machine learning? Now that will go. That I'll skip this big data, you know, right? Okay, now the big data I will skip. Then I'll go to the third approach. What is this third approach? Learning approach. What is learning? See, system doing the same task more efficiently next time. That means practice makes man perfect. So here constructing or modifying what is being experienced. That is the learning, right? Now this is very important. Simple sentence, but very useful. Learning is making useful changes in our mind. That is learning, right? Now, what is machine learning? Refers to a system capable of autonomous acquisition and integration of the knowledge. So, your system should have a capacity to autonomous acquisition. That means in a Google map, again you give a source and destination. In between, you get stuck with some problem or a road repair. Immediately, it will reroute and will get the data and integrated with that current situation and give the exact ETA, estimation of time of arrival. Okay, that Machine learning is nothing but now you have to see here the difference between traditional and machine learning is now this will give the data and program will get out. But whereas in machine learning will give the data, your output will be the input. Then what is your output? Your program, small program that we embedded in your smart mobiles. Okay, that is the difference. Now you want to be expertise in machine learning, you should know different concepts, statistics, information theory, databases, data mining, control theory, all these things you should be expertise when you want to be expert in machine learning. What are the machine learning types? Now, third approach is learning approach. In this learning, now we are having three types of learnings. One is supervised learning, unsupervised learning, then reinforcement. When do you use supervised learning? When data is labeled data. Okay. Now, when you use unsupervised learning, data is not labeled. Now, when we use environment is unknown. Environment is unknown, we use reinforcement learning. Now, your 80 to 90% of your data is not labeled. Then we cannot use supervised learning. Then what you will do now? So very simple definition I will take. Task of AI. AI is a system capable of doing three tasks. What are the three tasks? One is prediction. Second one is classification. This is second one. First one is a prediction. Third one is clustering. So AI is a system capable of doing three tasks. What are the three tasks? One is prediction, second one is a classification, third one is a clustering. Now your data does not have the labels. Then what do you do? Previously we are going to unsupervised learning. Now current trend we are not going to unsupervised learning. Now what we are going to this algorithm. What this techniques? What is that? Gen AI. What is Gen AI? Generative AI. Generative. What it is? Generative AI is a system again capable of generating content. What is that content? That content may be text or image or video or audio, anything. Here, what is our content? Our content is labels. Now you can generate the labels through generative AI. You generate the labels through generative AI. So for that we are using. Here important problem is classification. Here important problem is clustering. When do you say this is a good classifier? Classification error should be very, very minimal, distinct classes. We should not have overlapping classes like this. When do you say good cluster? Now you have these three things, data points. Now when do you say it is a good cluster, right? So this distance should be minimum. Between these should be maximum. That means intra-cluster distance should be minimum, inter-cluster distance should be maximum. Then we say this. These are three types of important types of machine learning, right? Now see this algorithm here. Here reinforcement learning. Environment is unknown. Agent is observing, describing this. Water and fire. Observe. Select using policy. Action. Get reward and penalty. Update your policy until you get optimal. Now these three boxes, this will describe you descriptive analytics. This is the predictive. This is a prescriptive. So very simple to understand these three data analytics is when you go for a shopping. Now what are the dress material you are seeing? Material you are telling. This is a brand, price, color, pattern, all are descriptive. Then you will take some dresses and go for wearing, fitting. You will check, right? That is called predictive analytics. Then you come for billing, right? That time you use a prescriptive analytics. That is optimizing your number of dresses with respect to many available. So this is the three types of learning approaches. Then machine learning has some problems. Then we are going for deep learning. What is the exactly deep learning? It will extend the number of several layers of nodes between input and output. Why deep learning become so popular? I told you, because of GPU. What is GPU? 8 into 10 to the power 12 operations per second it will do. Right? That is the power of deep learning. Right? Now see, the deep learning has three models. I will quickly. Now in machine learning, they'll extract the features, give the classification and output. But deep learning, the model itself will do the feature extraction and classification. Three models are there importantly in deep learning. This is that deep neural network, convolutional neural network, then recurrent neural network. This is used for image classification. This is used for language models and time series models, and this is used for forecasting models. Okay. Then this CNN, again we have pre-trained models or transfer learning models that we call as an AlexNet, GoogleNet, ResNet, InceptionNet. Here we have an LSTM, a long short-term memory. These are the different learning models which we can use. Okay, I will summarize quickly. What is AI? How we can teach AI? AI is inspired from human analogy. What are the human five senses? Eyes, ears, nose, and tongue. With that, they develop lot of AI models. Okay, AI technology. So this AI has a three types. One is a narrow AI, general AI, super AI. This AI has a three approaches. What are the three approaches? One is an expert-based approach. Second one is an intelligent-based approach. Third thing is a learning-based approach. So first, intelligent expert-based approach works based on the rule-based. It has for all our problems are dynamic in nature. That's why it is very difficult to adopt. Then we move to the intelligent. In intelligent, we have seen ANN, genetic algorithm, PSO, and ACO, then fuzzy logic and physics. In learning, we have a machine learning, deep learning, even we have a transfer learning, federative learning and all. Due to time, I am not going depth in that. Okay, so now in that machine learning, if you learn properly, then you make a mission to learn properly. Okay, there are three models: supervised, unsupervised, reinforcement. In deep learning, we have three models: DNN, CNN, and RNN. Okay, with these details, now why? See, all these things you can compare with the human analogy. Then you teach the student. Definitely, they will learn more in detailed manner. Okay, thank you. Thanks for the opportunity. If you have any queries, we can. These are some differences. We required data accuracy, training time, and all. Machine learning requires very less data. Here requires large data, accuracy, high accuracy, and less accuracy. Then takes a longer time. Here takes less time. So this longer time for training can be reduced by QPUs. Hardware requires GPU, CPU, then hyperparameters. These are the different tools are available in deep learning packages. Madam?
Thank you so much, sir. It was an informative presentation. Thank you so much, sir.
Have any queries and clarification?
Yeah, participants, any queries?
Definitely, I will share the PPT. Then no problem. Okay, thank you. If
Yes,
there
over
may
to
be
the
useful.
punch. Yes, sir. We have a small winding up session.
All right. Of course. Thank you, Dr. SRINIVASULU REDDY, for your enlightening session and for sharing your deep expertise in artificial intelligence. We deeply appreciate your time and effort you took to engage with us today, and looking forward to learning a lot more from your work in the future. And on behalf of all the participants, thank you for being with us today and guiding us. And with that, we conclude our today's session. Thank you once again, sir.
Thank you. Thank you, all the participants, for evening time. That was Saturday, and right?
Thank you, sir. Thank you.
Thank you, madam. Thank you, sir. Thank you, sir.
Thank you so much, sir. Thank you, sir.
Thank you once again, sir.
Thank you all.
Thank you.
Shall I leave, madam? Yeah.
Yes, sir. Yes, sir.
Yeah, thank you.
Thank you.
I also will share the attendance and the feedback form, so kindly fill it as